Good morning, my dear friends. Welcome to Veranda Excel. So, in today's session, we'll be looking at a very interesting topic. So, as the slide also says, we'll be looking at the concept of time value of money. When we say time value of money, broadly we talk about the concepts of present value and future value. So, these are the concepts we'll be discussing in today's session. In fact, these concepts of present value and future value are a very integral part to economic theory and more so finance theory. When you go to inter level and final level, you will not be seeing any topic on finance without looking at these concepts of present and future value. Therefore, it's a very integral concept and it's a very vast concept also. The applications of these concepts are very huge. But the idea today is not to see everything regarding this one, but at least to get an overview. As I used to say, or one of the joke also comes in the movie, for any building, if the basement is weak, however you build on top of that particular basement, it is still a weak building only. So therefore, the basement should be very strong, then only the building will be strong. Otherwise, the building is strong, sir, but the basement is weak, sir. Like that, your base foundation will not be very strong. Therefore, the idea is today to lay a very good foundation on this particular concept of present value and future value. So, that being the agenda for today's session, let's get started off with the concept of present and future value. Now, when we talk about value of money, broadly there are two values. One, as this particular slide says, the concept of present value is there, and other, the concept of future value. Now, what is present value? Again, don't get boggled when you hear these terms, especially most of you who are doing foundation will be hearing these terms new. So, don't get boggled. Oh, what is the present value? What is future value? Nothing. It's very simple. It's all concepts that you have seen earlier in your earlier school discussions, or even before that, or in your other college discussions. You would have definitely come across these terms, but in a different manner you would have come across. For example, if you see, this concept of present value is nothing but the term principle. Have you heard of the term principle? Right, that you have seen. So, that concept of present value is nothing but this concept of principle that you would have heard. Therefore, the term present value is nothing but the term principle. When we say the term principle, what is principle, sir? Very simple. It is the value excluding interest. It is the value excluding interest. So, whatever amount is there, if we exclude the interest from that, that is the principal part of it, correct? Now, broadly, just to recollect, let's assume you put a deposit of money for 10,000 rupees, you earn an interest of, let's say, 500 rupees, right? And totally, after, let's say you put this in a fixed deposit, this 10,000 you put in a fixed deposit, let's say for so many number of months you put, let's assume, right? So 5% interest you get, therefore it's 500, maybe you put for a year, nowadays it's only 5% interest, right? So therefore you get 10,500. Now here, 10,500. Now here in this particular example, you please tell me, out of these three numbers, which is the principal component? This 10,000 what you are investing, that is the principal component, correct? And this is the interest component, this 500 is the interest accrued for that 1 year. And what amount you are getting along with interest, that is called as the amount, is it not? So these are the broad terms that we use, very simple, very basic. Fixed deposit you are putting 10,000, interest accruing 500, and you get it after 1 year, you get the value of 10,500, you get it back from the bank. So therefore that 10,500 is the amount, 500 is the interest, and 10,000 is the principal, is it not? Very simple. Right now, therefore, what is this present value? It is nothing but this principal amount that you are investing. That is nothing but the present value. So therefore, it is the, when we say the principal, it is the value excluding this interest, is it not? This 500 interest is not included here. Therefore, the value excluding interest, that 10,000, that principal, that is the present value. Very, very simple. Whereas, what is the future value? Future value is nothing but this amount. In our example, what this amount of 10,500 is there, that 10,500 is the value including that 500 rupees interest, is it not? So that value including interest, that amount, that is nothing but the future value. Therefore, to put it very simply, therefore don't get scared by these terms, present value, future value, all that. The present value is nothing but the principal, and the future value is nothing but the amount including interest. So that is what is given there in this particular slide. So therefore, present value to recollect is nothing but the principal, the value excluding interest, Whereas future value is nothing but the amount. What is the amount? Amount is the value including interest. It is the value including interest, is it not? Therefore, these are the two terms. Sir, what are these terms? Present value, future value. We can just call it as principal and amount, na? So therefore, to understand why it is called as present value and future value, let me give you one example. Now let me just touch upon, now I am going to give just the introduction. I am not going to go too much in depth. I am just giving the introduction. This similar introduction is, or this similar example is what you will see in your inter-level, final level, at much more advanced level you will see. But now I am just going to give the introduction to that concept, why it is present value, why it is called a future value. Just to get that terms in your head, I will give you an example. Let's take a very common sense example. Now, let's assume there is year 0, right, or we will say time 0, whatever you can call it, and year 1. When I use the term year 0, I broadly say it is the time now, present, not the future, present, now, right. So that time now is nothing but the, we call it as term 0 or year 0. Whereas year 1 is sometime in the future. What is year 1? Normally it is at the end of 1 year. Let's assume after 1 year, 1 year after. Okay, now let's keep these terms in mind. Now, my dear friends, these terms you have to really get used to this terms of T0, T1, Y0, Y1, so on and so forth. You have to really get used to these terms. So normally Y0 or T0 means now, whereas Y1 means 1 year afterwards, right. So all these terms, please get used to it now itself. Now, let me give an example. Suppose somebody, let's say your debtor or somebody, your friend or somebody is saying, they'll give you 1,000 rupees now, right now, they'll give you 1,000 rupees, very good friend. Okay, so what is that, punya you have done in your past lives, whatever, he is saying, I'll just give you it, I like you very much, I'll give you 1,000 rupees right now. Okay, so that is one option he is giving. Or second option, the person says, or that, let's say somebody, debtor says, your friend or your debtor, somebody says, I'll give this same 1,000 rupees 1 year after. So this is option 1, this is option 2. Okay, let's take it very simple example we'll take, just to get your concepts very clearly. So option 1, now itself they will give that 1,000 rupees, whereas option 2, the same 1,000 rupees they will give after 1 year. Sir, no sir, I want the third option, sir, I want both 1,000 rupees now and 1,000 rupees after 1 year. I am not talking about either this or that, mutually exclusive. Either you get 1,000 rupees now or you get 1,000 rupees after 1 year. Now, as a common sense, leave aside economic theory, leave aside finance theory, as a common man, common person, what will you choose? Will you choose to receive this 1,000 rupees now, or will you choose to receive this 1,000 rupees after 1 year? Common sense, you tell me. No need for any calculation. Very simple. Everybody, any common sense person, regular person will choose the option of receiving 1,000 rupees now itself, correct? Money in hand is, what I said, bird in hand is worth greater than whatever, 2 after some time. That is the old saying that is there in English. But, so this is common sense. But same concept, economic theory or finance theory can prove using calculations why this 1,000 rupees now, 1,000 rupees now, it is worth more than 1,000 rupees received after 1 year. More than that, this 1,000 rupees now is worth more. How? There are two ways in which you can calculate. The very foundation of economic theory, there are certain principles. Please understand, any money received now at time 0, it is deemed to exclude interest. Note these points very carefully. Now I am going a little bit technical, therefore please keep your brain very sharp, right? So just try to focus on what I am saying. The very fundamental assumption of finance theory is that any amount received now, it is devoid or excluding any interest at all. It does not contain any interest at all. Whereas any amount, any money received in the future, it may be 1 day, it may be 1 month, it may be 1 year, any amount received in the future, it is deemed to include interest. Are you able to follow? Any amount received now is deemed to exclude interest. It does not contain any interest at all. Whereas any amount received any time in the future, it is deemed to include interest. If it is received after 1 day, it is deemed to include 1 day interest. If it is received after 1 month, it is deemed to include 1 month interest. If it is received after 1 year, as is the case, it is deemed to include interest for 1 year. Okay, this basic assumption is there in finance theory. So please keep this in your mind. This helps in calculation. Now, once you understand this assumption, now please tell me, can you compare this 1000 rupees received now with the 1000 rupees received after 1 year? Are they comparable figures? Answer is no. Why? Because one figure excludes any interest, another figure includes interest. Therefore, you cannot compare them. One is monkey, other is donkey. You cannot compare them, right? Therefore, then how to compare, sir? These two figures, to understand which option is better, how can I compare and do calculations, sir? Very simple. That is why there are two ways in which you can go about it. One, here this amount of 1000 rupees is excluding interest, correct? Now, let's assume the interest rate is 10% per annum. Interest rate, let's say, is 10% per annum. Nowadays, it's 5% only, but for easy calculation, let's take 10%. Now, interest 10% per annum, let's assume. This figure is excluding interest, correct? Whereas this figure is including interest. Can I do one thing? Can I bring this figure like this and add interest and make this figure as including interest? Can I do that? How can I do that? Very simple. I calculate interest for 1 year on this 1000 rupees at 10%. It comes to what? 100 rupees, is it not? So, I will add this 100 rupees interest and I will calculate the value. Now, this 1000 becomes 1100 after 1 year. So, this includes interest, correct? Therefore, now you can compare this figure and this figure. Therefore, you please tell me, now this 1000 rupees excluding interest, we have added the interest and we have brought it as including interest, correct? So, this option 1 figure, now we have recalculated as including interest. Now, this 1000 rupees received after 1 year, it is already including interest. Therefore, don't include interest once again. Therefore, now you please tell me which figure is higher, this figure or this figure? This figure of 1100 is only higher. Therefore, because of that, we are able to say that this 1000 rupees received now is better. Are we able to follow? Therefore, to compare these two values, option 1 and option 2, to compare these two values, we are bringing them on the same footing. What footing? We are bringing both amounts as including interest, then we are comparing. Then we are able to easily say through calculations, we are able to establish that this 1000 becomes 1100 if it is including interest. Therefore, this is better. 1100 is more than 1000. Therefore, I will prefer this. You are able to prove this. Are you able to follow? Therefore, to bring comparability of cash flows, we call these things as cash flows. Please get all these terms in your mind. So, to have comparability of cash flows received in different time periods, to ensure comparability, we use this concept of, what is this calculation now including interest called as? This is called as the future value. Please understand, this 1100 is the future value after 1 year of this 1000 rupees. Are we able to follow? So, therefore, this amount we are calculating including interest. It is called as the future value. Why we are calculating this future value? So that we can compare with another cash flow during the same period. Are we able to follow, guys? Now, this is one way of comparison. Therefore, we are able to establish that 1000 rupees received now is always better. There is one more way in which you can calculate. How you can calculate? Let's see another way of calculating. Let's take the same year 0 and year 1. Right now and after 1 year. Let's take the same rupees 1000. Option is being given. First option, receive it now. Second option, received after 1 year. Now, what we did in the last working, we made this, as we already seen, this 1000 rupees excludes interest, whereas this includes interest, correct? That is the basic assumption of finance theory, time value of money theory. Therefore, having seen this, last what we did, we converted this figure excluding interest as including interest. We calculated the future value and then we compared, is it not? There is another way of comparing. How? This figure is excluding interest, this figure is including interest, okay. Can we bring this figure including interest like this and make it as excluding interest? Can we make it as excluding interest? Can we do like that? Then once we make the second figure as excluding interest, then we can compare with the first figure which is already excluding interest. Therefore, now we can compare. Therefore, this is another way, going like this and making the comparison. This value, if we calculate excluding interest, it is called as the present value. How to calculate present value? We have already seen present value is nothing but what? Principal, correct? It's nothing but P. remember your compound interest formula. Now to derive this formula of a present value, it is not any something new, right? It is very easy only. How? Very simple. Remember your compound interest. What is the formula for amount under compound interest? Please recollect and tell me. The formula for amount is nothing but P into 1 plus I whole power n, is it not? Long ago, so long ago, somewhere we have seen this, right? Therefore, we know that amount is equal to P into 1 plus I, principal into 1 plus interest whole power number of years. Now, I already told you that this amount is nothing but future value, correct? Therefore, this P is nothing but present value, is it not? We just discussed this. Then how to derive a principal or PV? Very simple. This P cross multiplying, you get P is equal to A by 1 plus I whole power n, or we can also say PV, P is nothing but PV, A is nothing but FV. So PV is nothing but FV divided by 1 plus I whole power n. P is nothing but A by 1 plus I whole power n, correct? So same way we can derive. Therefore PV is nothing but P, having seen that is nothing but A divided by 1 plus I whole power n, we can use this particular formula. Therefore now substituting, what is A here? This amount including interest is A, 1000. Let's keep the same interest rate at 10% per annum. Okay, so therefore divided by 1 plus I comes as 10% comes as 0.10 in terms of decimal. Okay, whole power n is 1 year, because now we are seeing year 1, y1, so 1 year. So having seen that, we are able to say it is nothing but 1000 divided by 1.1 whole power n, I can just say 1.1, it comes to somewhere around 909 something if I am right, 909.09, so on and so forth, roughly speaking. 910 rupees, somewhere it is coming, is it not? Therefore, having seen this, now this 909 is excluding interest, because we have found out what? Present value, correct? It is always excluding interest. Therefore, this 1000 future value, if we calculate the present value, it becomes 909.09. Therefore, this is excluding interest. Therefore, now you can compare this figure and this figure, you can compare. Therefore, now tell me which figure is better. Again, you are able to say that this 1000 rupees received now is more than that 909, present value of that 1000 rupees received after 1 year. So 1000 is more than 909. Now both are excluding interest. We can compare and say that 1000 rupees is higher figure. Are we able to follow? Now we can compare and say this again, first option is better. Therefore, after all these calculations, what we already know, what is that? Any bird in hand right now, money in hand right now is always better than the same money after some period of time. So we have established using this calculation. Sir, why this calculation, sir? Very simple. No, we already know this concept. No, please note it is not as simple. Now I am giving a very simple example for you to understand, right? But the idea, please understand, of present value and future value is to compare two values or two cash flows spread over various periods. You cannot compare them directly. So one is received now, one is received after 1 year. You have to do either the present value calculation for the year 1 figure or the future value calculation for the year 0 figure, then bring them on the same footing, both including interest like the last one we have done, or now excluding interest like what we have done here, right? So either the present value you have to find out like this, or future value you have to find out like this, then you can compare, then you can get the answer. Are we clear? So anyway, if you are able to understand this concept, it's great. Otherwise, finally at the end of it, please remember this formula. That's about it. What is the formula? 1 for present value. Okay, let's go see this as the first formula. At the end of the discussion, if you remember this formula, it's enough. First formula, what is that? Amount, future value. Amount is nothing but future value. So future value is equal to PV into 1 plus I whole power n. So that's how you calculate future value. Please keep this concept in mind. And same way, by reverse working, we can say second formula is this one. Present value is equal to A divided by, or future value divided by 1 plus I whole power n. So these two formulas you keep in mind. And also please keep in mind the various terms. Present value is nothing but principal. Future value is nothing but what? It is nothing but amount. Present value is principal excluding interest, whereas future value is amount including interest. Are we clear? So this is what is given in the slide also, my dear friends. Have a look at this, right? So if you have a look at this particular slide, that is what I am reiterating again. Present value is nothing but principal excluding interest, formula is given, and future value is nothing but amount including interest, the formula is given. Are we clear? What we discussed, same thing is given in the slide also. So having seen that, anyway, you can just go through it once more, right? Now moving forward, so having understood this concept of present value and future value of a single cash flow, what we have found out is the formula for the present value and the future value of a single cash flow, single 1000 rupees like that. Whereas what if it is not a single cash flow? Let's say you receive 1000 rupees, same 1000 rupees, you receive it as an annuity. As an annuity means what? Year on year you receive, right? So let's assume somebody is good enough, or somebody is a good person, or you have put some annuity in some pension fund or LIC or whatever, and after that insurance plan matures, they'll say they'll give you an annuity. I'll give you an annuity, sir. Every month you take a pension of 1000 rupees, I'll give you. Therefore, suppose it is a 1000 rupees, not a single cash flow, but it is received over 4 years or received over n number of years. Same 1000 rupees every year they are giving you, or every month they are giving you, or every quarter, whatever it is, they are giving you. So in that case, for this cash flow, how to find out the present value and how to find out the future value? That is what we have to see. Therefore, now we discuss the concept of present value and future value of a cash flow like this, of an annuity like this, right? So before that, let's first discuss what is an annuity. Then we will see how to find out the present value and future value of an annuity, right? Now, as we have seen, for an annuity there are certain features that are required. Certain features are required. But before I tell the features, I will show you an example. You will understand it much better. Now there are 4 examples, 1, 2, 3 and 4 given. Now your job, and your answer is given, but without looking at the answer, you have to tell me which of this is an annuity. First example, just 5000. Only 5,000 received. Is it an annuity? Second, 5,000, 10,000, 5,000, 5,000 and 5,000 over 5 years it is being received. Is this an annuity? Third, 5,000 first year, second year there is nothing. Third, fourth and fifth year 5,000 received. And last one, all 5 years 5,000 received. So which among these 4 examples is an annuity? Very simple. First one is not an annuity. Why? Because annuity should be a cash flow. There should be more than one 5,000, correct? A single transaction is not an annuity. Therefore, it's a single transaction, therefore first one is not an annuity. Second one also not an annuity. Why? Because look at it, second year the amount is changing. It is becoming 10,000, correct? Therefore, 5,000 first year, 10,000 second year and again 5,000 repeated. This is not an annuity because the cash flow should be equal also. So, this is not an annuity. Third one, have a look at it. That's also not an annuity. Why? Because annuity should also be regular. Every year means every year it should be received. Every month means every month it should be received. Whereas here second year you are not receiving it. Therefore, that is also not an annuity. Whereas the last example, 5,000 all 5 years, that is an annuity. Are you able to follow, guys? Therefore, out of these 4 examples, the last example is the annuity. Are you able to follow? Therefore, what are the features of annuity, sir? 1, it must not be a single transaction, it must be a series of transactions. First feature. Second feature, it should be equal. There should not be one item which is different, they should all be equal. Second feature. Third feature, there should not be some missing item, it should be regular. Are we able to follow? So, all these features are there, then it is called as an annuity. This contains all the features. I will repeat. 1, there must be a series of cash flow, not one item. Second, it must be regular. And third one, when I say second, it must be equal. All the amount should be equal. And third one, it should also be regular. Regular means every year should be there. 1 year should not be missing. All these features are there. That is an annuity. Why is this important? Because now what formula for present value of annuity, future value of annuity, like that we will see the formula. That formula is applicable only for which situation? When I now we will discuss the formula next. It is applicable for which situation? It is not applicable for first, second or third. We cannot use that formula. We will discuss in the next few minutes. What formula we are going to see now for present value and future value of annuity, that formula is applicable only in the 4th situation. Are we clear? If you misuse the formula, then the answer will be wrong. So therefore, now the formula we are going to see next, that is applicable only for an annuity. What is annuity? Something like the fourth one. Now let's see some practice. Sir, I don't understand still, sir. Can you give me some real life example of annuity? I'll give you. You take the example of a rent. Please note, annuity can either be a receipt annuity or it can be a payment annuity, correct? For example, rent, you're a landlord, you're receiving rent, good, very good. So you're receiving rent. So rent received monthly, you're receiving, let's say, some 5,000 rupees, 10,000 rupees rent. That rent received monthly is a receipt annuity, it's an annuity, correct? Salary, over the short term, salary is an annuity. Retired person, pension they'll receive, pension is an annuity. So all these are examples of receipt annuity, interest received sometimes. So all these can be annuities. Are you able to follow? So therefore, rent received, salary received, pension received, all these are receipt annuity. Now let's take payment annuity. Look at from company's perspective, salary paid can be an annuity. Same way, rent paid, pension paid, LIC, let's assume you're an individual, you are paying an LIC premium, premium paid. All these, if you see, they are examples of annuity. Therefore, please understand, annuity can either be a receipt annuity or it can be a payment annuity. I have given you many examples, so you can think on the same lines. So if it is an annuity like that, then to find out future value and present value, we can use a formula which we will discuss next. Sir, then what about the first three situations, sir? Please note, you cannot use that formula, it is wrong. Then what formula to use, sir, to find out present value, future value? We have to use the earlier formula, what we have seen now. The earlier formula you have to use and you have to find out the present or future value. You cannot use the next formula we are discussing now. So therefore, now let's go to the formula. The fourth situation, if it is an annuity, then what is the formula for present value and future value of that annuity? Now let's take an example again, right? So let's take an example again wherein same 1,000 rupees received at the end of year 1, year 2, year 3. Alright. Now what is the idea? What are we going to find out? Look at this. Interest rate is 20%, let's assume. Very higher interest rate. Such banks or such financial institution, please go and put your, maybe if it is a credit worthy thing, you can put your money. Nobody gives 20% nowadays, but let's assume for easy calculation purpose. 20%, 20% is 0.20 in terms of decimals. Therefore, interest rate at 20%, what are you required to find out? You are required to find out future value at the end of 3 years. At the end of 3 years, what is the future value? Please understand, my dear friends, future value means what? It is nothing but the amount including interest, correct? So therefore, you have to find out the amount including interest at the end of 3 years, right? So that is what is given here. Now how to find out? Now there is a formula for this, because it is an annuity. Have a look at it. Is it an annuity? 1,000 rupees, same 1,000 rupees for 3 years. Is it an annuity? Yes. Therefore, there is a formula. But before seeing the formula, let us prove the formula. Otherwise, you will ask me, sir, how? Please show me the proof for this. We will see the formula, proof for that formula. Now, let's find out the future value now using the formula. Already we know. Individually, let's find out the future value for these 1,000 rupees separately. How? What we did in that earlier example, like that you find out. For that, use this formula, right? For each and every item separately, use this amount or future value formula and separately find out future value. Then you add up everything, that is the future value of the annuity, correct? Therefore, let's go by the known formula and find out individually, let's find out the future value. Then once we add up everything, that is the future value of the annuity. Anyway, we will see. For example, let's take this year 1, 1,000 rupees, let's assume it is there. Now please understand, remember these things very clearly. This 1,000 rupees includes interest, correct? Sir, then what are we doing, sir? We also want to find out amount including interest. No, please note, this includes interest for 1 year. Why? Because it is received at the end of year 1. Whereas this year 2, 1,000 rupees, it includes interest for 2 years. Whereas this includes interest for what? 3 years. Okay? Therefore, please keep this in mind. Whereas what we want now, all these things we want to convert including interest for 3 years. For example, have a look at this, already includes interest for 1 year. Now we have to add 2 more year interest. This includes interest for 2 years, therefore you have to add 1 more year interest. This includes interest already for 3 years, therefore there is no further interest that is required, so no interest you will add because already it contains interest for 3 years. Okay? Therefore, how to do that, sir? How to add 2-year interest, how to add 1-year interest, so on and so forth. Very simple. Use this formula for amount. A is equal to P into 1 plus I whole power n. Therefore, for this first one, 1000 rupees, this P becomes 1000. Okay? And 1 plus I is nothing but 1 plus interest rate is 0.20, as we already seen here. 20% interest, so 0.20, so it becomes 1 plus 0.2, 1.2. Now please note how many years interest we have to add. It already includes interest for 1 year. Now you have to add 2-year interest, correct? Therefore this n power becomes 2. So same formula, A is equal to P into 1 plus I whole power n. Therefore substituting the values, and this n becomes 2 because 2 years interest has to be added. So if you calculate, it becomes 1440. So this is the 1000 rupees at the end of 1 year becomes 1440 at the end of 3 years, including interest for 2 more years. Same way, applying this concept for second 1000 rupees, now again it becomes 1000 into 1.2, this is same, but here power becomes 1 because we have to add interest for only 1 year, correct? Therefore power becomes 1, therefore it becomes 1200. Third one also same formula, but here power becomes 0. Why? Because no interest to be added, correct? Therefore power becomes 0. So anything power 0 is 1, correct? Therefore it becomes 1000 itself. Therefore, if we add up everything, it becomes 3640. Please note, this is the future value of annuity. Annuity means what? All these 1000 rupees, if you take interest for 3 years, the total value of these is 3640. Just you add up 1000 rupees, 3 times it becomes 3000. But if you include interest for 2 years, 1 year and 0 years respectively, after including interest for whatever balance period left out, it becomes 3640. I hope you are able to correlate. Now the same 3640 we can arrive using a formula. No need to do like this for each and every sums are very difficult, sir. One you are doing calculation. Just to prove I have given. But easily you can get the answer using a formula. How? Look at this. This is the formula for future value of annuity. The formula is like this. Now please note the notation. Some books they use it different. Some authors they use it different. But you can just correlate with the explanation I have given. The future value of the annuity is given by the formula R by I 1 plus I whole power n minus of 1. So here I think everybody knows what is I and what is n. I is the interest rate, n is the number of years. That everybody knows. Whereas what is this R, sir? R is nothing but the regular cash flow. In our example, the 1000 rupees is regular cash flow, correct? That is the annuity. So that is R. Some people use this as P, but if you ask me, P may not be so correct. But anyway, whatever it is, regular annuity. Therefore, now again I will repeat the formula so that it gets etched in your mind. What is the future value of annuity? It is nothing but R by I. Please note, then within bracket, whole bracket, and within that one more bracket, 1 plus I whole power n minus of 1, close bracket. R by I 1 plus I whole power n minus of 1. Are we clear? Therefore, now substituting all these terms here, therefore now this R becomes what? Now substituting it here. R is 1000, regular cash flow, interest rate 0.20, please note everything converted into decimal. Then here 1 plus I, 1 plus 0.02 whole power n is 3 years minus of 1. Therefore, now doing the calculation, this 1000 divided by 0.2 becomes 5000, this becomes 1.2 whole power 3 minus of 1. Now this 1.2 whole power 3 becomes 1.728 minus of 1 becomes 0.728. So 5000 multiplied with that becomes 3640. It is the same answer what we have got, correct? What we have got on the last slide, same 3640. Are you able to follow, guys? Therefore, no need to do like this and all. This is just for proof. In exam they ask a problem, you use this formula, get the answer. Same 3640, very simple. Done. Now same way, so this is the formula for future value of annuity. Same way, what is the next concept? Present value of annuity. Now same example is given. Here again I have shown the proof, how to find out. I have shown the proof. Okay, but I am not going because we can go by the same formula, because present value now we have to find out. One second. We have to find out present value, we have to find out P, using the formula A by 1 plus I whole power n separately for each of the items you have to find out using this formula. Already we have seen the formula. P is nothing but A by 1 plus I whole power n, correct? So same formula you can use for finding out PV individually for each cash flow and then add up and get the present value of the annuity. Okay, but I am not showing the proof. Straight away I am going to the formula. Present value of the annuity. Formula is very simple. See, there are n number of formulas which are being used, but I like to keep things very simple. Present value of the annuity is nothing but future value of the annuity divided by 1 plus I whole power n. Sir, what is future value of annuity? Already we have seen one formula, no? R by I 1 plus I whole power n minus of 1. Use that, find out future value, first step. Second step, present value. If you want to find out, is nothing but future value divided by 1 plus I whole power n. You will get the answer. Therefore, in the last example, same example we have taken, we have found out the future value, correct? What was it? It was 3640, correct? Divided by 1 plus a whole power n. Same interest rate 20%, so 1.2, whole power n is 3. Therefore, denominator becomes 1.728, numerator is same 3640. If you divide that, you get the answer 2106.47, which is the answer here also. So this is the PV of annuity I have got. Same answer 2106. You without this calculation and all, individually calculating and then adding up, nothing required. Use the formula, get the answer. Are you able to follow? Now, please note, this is the formula for present value and future value of annuity. In case it is a yearly annuity. Sir, what if it is a monthly pension I am receiving, sir? Or quarterly amount I am receiving, sir, quarterly pension I am receiving, quarterly rent or interest I am receiving. So if it is monthly or quarterly, then what I should do, sir? Very simple. I always used to say formula is same, but I always used to say whenever it is multiple compounding means what? Nothing but monthly, quarterly, half yearly. So in case of multiple cash flows during the year or multiple compounding, we used to say monthly receipts are there instead of yearly, quarterly are there, half yearly are there, then what to do? Formula is same, but I just use the concept of capital I and capital N instead of small I and small n. So what is capital I? So say therefore present value of annuity will come. What is capital I, capital N? So present value of annuity therefore becomes future value of annuity divided by 1 plus capital I power capital N. Whereas future value of annuity is same. I will just rewrite it so that it becomes very clear. R by capital I 1 plus, let me write it like this, 1 plus capital I whole power capital N minus of 1. Just use capital I and capital N, that's it, instead of small I small n. So what is capital I capital N? Therefore that will be the next question. Very simple. Capital I is nothing but small I divided by m, whereas capital N is nothing but small n multiplied by m. Capital I, small I divided by m. Capital N, small n multiplied by m. Divided by, multiplied by. Sir, then what is this m, sir? Very simple. M means the number of compounding terms in every year. Number of compounding terms means what? Very simple. You tell me. If it is a monthly annuity, in 1 year, how many annuity will be there? 12 annuities will be there. That is the number of compounding terms also. If it is quarterly means, every year, how many quarters will be there? 3 quarters, sir. No, 4 quarters, right? So 4 will be the number of annuity per annum. Half yearly means 2 payments or 2 receipts will be there. So therefore this m becomes, if it is monthly given, you have to put it as 12. Quarterly 4, half yearly 2, so on and so forth. Are we clear? So that m, in case of capital I, small I divided by m, whereas capital N, small n multiplied by that m, multiplied by that m. Okay, you have to substitute this, you will get the answer. Fine, my dear friends. So this is in case of multiple compounding, you have to just substitute same formula only, but small I small n instead of that capital I capital N you have to put. Now one more concept you will see. Now if you note very carefully, in all our examples, I have taken the cash flow at the end of the year. Sir, what if the cash flow happens at the beginning of the year itself, sir? Advance itself they are paying the rent every month. Beginning of the year it happens. Then what I should do, sir? Please note. So therefore there are 2 concepts here. One, if the cash flow happens at the end of the year, just like what we have seen earlier, it is called as ordinary annuity, normal annuity, regular annuity. Normal, that's a normal case. Normally rent will be paid at the end of the month only. So normal annuity, regular annuity, ordinary annuity. Whereas if the cash flow takes place at the beginning of the year, advance rent they are paying, very good client, don't leave him, very good tenant, don't leave him. Therefore, cash flows happens at the beginning of the year. Then how to find out present value and future value? First of all, this annuity is known as annuity due. Please note these terms very carefully. In exams, they will give beginning of the year, end of the year like that. Immediately you have to correlate with beginning of the year means annuity due, whereas end of the year means normal. If it is annuity due, formula for present value, future value almost similar, not the same, similar. Please note, in terms of a present value formula is same, future value divided by 1 plus I whole power n. But present value of annuity due, future value of annuity due divided by 1 plus I whole power n. So what is future value of annuity due? Formula is same formula only, but just multiplied with 1 plus I. Okay. So this multiplication with 1 plus I, that's the new multiplication of the formula. One term you have to multiply with the normal formula, you will get annuity due formula. Are we clear? Fine guys. So therefore this is in case of annuity due. Now let's quickly take a case study. We will try to just apply the concept. Right. Therefore now to recollect, we have seen the concepts of present value, future value of single cash flow, time value of money. Then in case it is an annuity, regular cash flow, then what is the present value, future value of annuity? Normal annuity, annuity due, all formulas we have seen. Okay. Now let's take a case study. With that we'll try to wind up the session also. Now let's take a case study wherein how much amount to be invested every year. Okay, that is what you have to find out. So as to accumulate 3 lakhs at the end of 10 years at 10% interest rate. Sir, what is this, sir? Very simple. They are asking you how much you have to invest every year. As finance professionals you are going to be, you have to tell how much invest every year to get 3 lakhs at the end of 10 years. If interest rate is 10% per annum. Okay, so I want 3 lakhs at the end of 10 years for what? Higher education, or yeah, for you're a student, you're planning higher education, or if you're a parent, your parent will be planning for your education, your marriage, so on and so forth. So many things they'll be planning. So at the end of 10 years, they want 3 lakhs. So your father is asking you, you are going to be a chartered accountant, you please tell me how much I should invest every year. I want exactly 3 lakhs. Exactly 3 lakhs only required, sir. Yes, exactly 3 lakhs required. Therefore, you please tell me how to do that. Therefore, now very simple. How to find this out, sir? Just take our formula. Okay. Now you tell me, I require 3 lakhs when? Now or at the end or in the future? In the future. 3 lakhs at the end of 10 years. Therefore, please tell me, is this present value or future value? First you have to identify that. This is the required future value because it is required after 10 years. So first identify that. How many years? 10 years, that is n. 10% is I. We will convert decimal 0.10. So then what is required, sir? How much to invest every year? This is the giveaway. The term every year indicates it's an annuity. Okay, so therefore this is the future value of annuity. So remember the formula. What is the formula? Future value of annuity. Therefore once you identify that, it's very easy. Once again. Okay, let me work it out. Therefore now take this formula, future value of annuity. Please note it is normal annuity. Nothing given, take it as normal. Formula is what? R by I 1 plus I whole power n minus of 1. Please remember this formula. Therefore now substitute, that's it, get the answer. What are you required to solve for? How much invest every year means what? This R you have to solve for, correct? So that regular cash flow, that is what you have to find out. So that is R. R you have to find out, everything else is there. Therefore substitute 3 lakhs is equal to R you have to find out, I is 0.10. 1 plus I becomes 1 plus 0.1 becomes 1.1. So let me write it very quickly. Whole power n, n is 10 years minus of 1. Okay. Now cross multiply, find out, get the answer. Therefore cross multiplying, this becomes 30,000, this 0.10, take it up. Now 1.1 whole power 10, let's try to find that out. Let's quickly do the working at your end also. So 1.1 whole power 10. Is it 2.8394? Right, so I hope all of you have done the calculation at your end also. Therefore, let me quickly recheck the calculation. Is it 2.89 or 2.5? One second. Yeah, 2.5937 if I am right. Yeah, 2.5937, correct? So therefore, this 2.5937 is the value for 1.1 whole power 10. Now subtract this with 1. Therefore, now after, so this is 1.1 whole power 10. Now we have to subtract this 1, becomes R multiplied by 1.5937. Is it not? So 2.5937 minus of 1 becomes this 1.5937. Therefore, now cross multiply. So R becomes 30,000 divided by 1.5937. Take till 4 decimal places, that's enough. Therefore, 30,000 divided by 1.5937, okay, becomes 18,824 point something something. Please check it at your end also. Therefore, this is the answer, my dear friends. So in this question, what is the answer or what is the meaning you are getting? You have to invest this 18,824 or around, if you round it off, 825 or something. 18,825 you have to invest every year. You have to invest for how many years? 10 years you have to invest, and if interest is also added, it becomes 3 lakhs. So this is what is called a small amount you are saving. It multiplies to a larger value, right? So 18,825 invest every year to get 3 lakhs at the end of 10 years, right? Now any questions are there? If any questions are there, we'll take up the questions, or else we'll quickly wind up with another case study. Any questions are there so far? Can we move on? Yeah, so all of you are either absolutely bold or very, very clear. So let's hope it's the latter. Anyway, let's take another case study so that you can confident. All these are exam questions. So in fact, this is an exam question which has been repeated, I cannot tell how many number of times in the CA exams. Again, a beautiful problem called as sinking fund problem. What is sinking fund? Again, very simple. All of you have come across this in accounts also. Sinking fund is a fund where you put some money every year or every quarter or every half year, so on and so forth, normally every year, to accumulate certain amount. So it is nothing but same as what we have seen in the last one. You have to find out that R. That R is the sinking fund amount or premium you will be paying every period. Therefore, sinking fund problem, it's popularly called a sinking fund problem. Now, what are you required to create the sinking fund for? You have a machine which costs 5.2 lakhs, estimated life of 25 years. You want to replace that with a new model which costs 25% higher. Right, so you want to replace it after 25 years. But the old machine, when you sell it off, you get a scrap off. You scrap it, you sell the old machinery, you estimate to get 25,000. Interest is 3.5%. So what are you required to do? How much amount should be set aside every year? So which means how much should be invested every year. So which indicates it's an annuity problem, every year, that word. And what to be set aside every year means you have to solve for R, right? Now in the last problem, if you look at it very carefully, you knew that you require 3 lakhs at the end of 10 years. But here how much you require at the end of 25 years? So this 25 years again, by the way, is N. So you have N, you have I, right? But what is the future value? That you need to know, correct? What is the amount you want at the end of 25 years? It's not straight away given in this problem. Now please understand, what is the future value required? What is the amount that you require at the end of 25 years? You want to replace the old machinery with new machinery, correct? But new machinery is not costing same 5,20,000. How much does it cost? It costs 5,20,000, right? And it costs 25% higher. 25% higher means what you should do? You can add a 25% on 5,20,000. So let's quickly do the calculation. Anybody has calculator, take it out, do it. Right? So 5,20,000 multiplied by 0.25, 25%, so comes to 1,30,000 more cost you have to incur. So 6,50,000. But please note, this 6,50,000 completely not required. Why? Because the old machinery, this is the cost of new machine. But you are selling old machine, correct? When you sell the old machinery, then only you are buying the new machinery. That selling the old machinery gives you the money of 25,000. That is given as the scrap value in this problem. You get 25,000. Therefore, you need not plan for it. Automatically, you will get. Therefore, if you reduce this, so this is the required amount. So even though the new machinery costs 6,50,000, but you require only 6,20,000 because another 25,000 you are getting by selling the old machinery. So take this as the future value of the annuity required. Okay. So having seen this, now let's work out. So 6 lakh, let's take the formula, future value of annuity. Let's repeat the formula once again so that we are very clear. R by I, nothing given, you take normal annuity formula. Right. So this is 6,25,000 which we have solved for. This is the amount required. R you have to solve. I is I think 3.5%, so therefore 0.035. 1 plus I therefore becomes 1.035. Whole par n, how much? 25 years you have to invest, so minus of 1. Now let's again quickly calculate. We require this, everything else is very clear. What we require is this 1.035 whole par 25. So let's try to calculate that. So 1.035 whole par whole par 25. One second. You get, if I am right, 2.3632. Take out your calculators and try to find out. Right? So you get this. Now let's find out the other values. So first cross multiply this here, 6,25,000 multiplied by 0.035, 21875 is equal to R multiplied by this 2.3632 minus of 1 you have to do now, so becomes 1.3632. So cross multiply this here. Okay. So before that, once again let me check this 0.035. Or 1.035 whole par 25. Once again let me cross check it. Yeah, 2.3632, great. Therefore now 21875 divided by 1.3632. You get the answer as 16,046 or 047. So you can keep till 4 decimal places. Fine. So therefore, you have to invest every year in the sinking fund, you have to invest 16,040. That is around 16,050 rupees. Every year you have to invest for how many years? 25 years at 3.5% annum. If you want to accumulate 6,25,000 at the end of 25 years to buy a new machinery. Are we clear? So this is the regular investment every year you have to make in the sinking fund. Right, my dear friends? So with this we have seen a couple of examples how to apply the concept of annuity, present value and future value formulas, how to apply we have seen in various case studies. These are typical case studies which come in your examination. Therefore, my dear friends, with this let's quickly recapture. So in today's session, what have we seen? One, let me erase all the calculations here. So first we have seen the concept of time value of money, which broadly comprise of two concepts. One is the present value, other is the future value. What is present value is nothing but the principal, which is excluding interest, whereas future value is nothing but what? It is nothing but the amount including interest. Point number 1. Now, having seen this, how to find out PVFE? We have seen the formula. For individual cash flow, we have seen that PV is nothing but P given as A by 1 plus I whole power n, whereas FE is nothing but A. Compound interest formula for A is equal to P into 1 plus I whole power n. So, PVFE formula for individual cash flow, we have seen that, right. Then we have seen the same concept of PV and FE of annuity. How to apply the formula, how to derive all this we have seen, right. So, with this I think we have given an overview, good overview as to concepts of time value of money and annuity, and so with this we will wind up the session also.